All right, let's dive into one of the weirdest things that can happen in algebra. We're going to investigate a real mathematical mystery where the clues are numbers and the suspects are the variables themselves.
So picture this. You're working through a problem. Everything seems fine. And then poof, your x and your y are just gone. It feels like you've messed up big time, right? But what if I told you it's not a mistake at all?
Seriously, don't panic. When those variables vanish, the equation is actually trying to send you a secret message. It's a clue, a really important one, about the problem you're trying to solve.
So, welcome to what I'm calling the vanishing variable mystery. For the next few minutes, we're going to put on our detective hats and learn how to read these algebraic clues to figure out what's really going on.
Here's the key idea you've got to remember. Algebra is visual. See, every linear equation is just the story of a line on a graph. And when you're solving a system of equations, you're just looking for the spot where those two lines cross. So when the variables disappear, it's because the lines are doing something, well, special.
This whole vanishing act, it can only lead to one of two outcomes, and I like to think of them as the lie and the truth. These are the two secret messages your equations might reveal.
Okay, this slide breaks it down perfectly. On one side, we've got the lie. This is when you end up with a totally false statement, something impossible like 0 equals 7. That means there is no solution. Geometrically, it's telling you the lines are parallel, they run side by side forever and will never ever cross. Then, on the other side, you have the truth. This is when you end up with a statement that's always true, like 0 equals 0. This means there are infinite solutions. Geometrically, this reveals that your two equations were actually describing the exact same line, just in a clever disguise.
All right, theory is great and all, but let's actually get our hands dirty. It's time to investigate some of these strange systems and see how this plays out in the real world.
Here's our first case file. We've got two equations. Now, right away, you should notice something kind of fishy here. Look at the left sides, the parts with the variables. They're identical, 2x plus 3y. But the right sides are different, 5 and 9.
Let's use the elimination method here. It seems like the obvious choice. If we just subtract that second equation from the first one, watch what happens. 2x minus 2x, gone. 3y minus 3y, also gone. The entire left side just became 0. And on the right, 5 minus 9 gives us negative 4. So we're left with the statement 0 equals negative 4.
And there it is, our first clue. Is 0 equal to negative 4? No way! That is a flat-out mathematical lie. The variables vanished and they left behind an impossible statement. So, our conclusion? This system has no solution. Those lines are parallel. Case closed.
Okay, let's move to our next case. This one looks a little different, right? The coefficients aren't identical at first glance. It seems like just a normal system of equations, but let's investigate a little deeper.
So to get our variables to line up so we can eliminate them, let's multiply that entire top equation by 3. That gives us a brand new system. Negative 3x plus 6y equals 12. And 3x minus 6y equals negative 12. Okay, now let's add them together. Negative 3x plus 3x is 0. 6y plus negative 6y is 0. And 12 plus negative 12 is also 0. Everything cancels out.
So what are we left with? 0 equals 0. Is that true? Absolutely. It's a fundamental truth. Our variables vanished and left us with a true statement. The conclusion here is that there are infinite solutions, because these aren't two different lines at all. They are the exact same line, just wearing different outfits. Now hold on. Every good detective needs to know how to spot a red herring, and there's a very common trap that can look like a vanishing variable situation, but it's actually something completely different. Let's not fall for this case of mistaken identity. So take a look at this system. You see the 2x and the negative 2x, and they're just perfectly primed for elimination, so it kind of feels like something's about to disappear. But let's see what actually happens. When we add the two equations, yeah, the x terms cancel out for sure. But wait, the y terms don't. We're left with 5y equals 15. Well, that's easy enough to solve. Y equals 3. And we can just plug that back in to find out that x equals 0. So this is the key takeaway, folks. Our solution is the coordinate point 0, 3. A variable equaling 0 is a perfectly normal, totally valid answer. It's just a location on the graph. This is completely different from the variable itself, vanishing from the equation and leaving behind something impossible like 0 equals negative 4. So let's just hammer this home. Here are the things to watch out for.
First, never ever confuse a variable equaling 0 with having no solution. Totally different things. Second, don't stop early. If you simplify an equation and get something like 2x equals 2x, you have to keep going. You got to finish the math to see if you actually get 0 equals 0, which means infinite solutions, or 0 equals some other number, which means none.
Okay, so we've been playing Math Detective for a little bit. But why? Why does any of this actually matter outside of an algebra test? Well, it turns out this is about a fundamental type of logic that applies pretty much everywhere.
Think about it like a science experiment. If you run 2 trials and get data that totally contradicts itself, that's our no solution case. It means something is probably wrong with your theory. But if you run the experiment twice and get the exact same data, our infinite solutions case, it means your results are consistent, they're reproducible. It's the same exact logic.
And that really brings us to our final thought. The ability to recognize a contradiction, our lie, versus an identity, our truth, is a skill that goes way, way beyond the math classroom. It's really a cornerstone of logical thinking. So the next time your variables vanish, don't panic. You've just uncovered a much deeper story.